Welcome, welcome. So we are taking a look now at factoring. The first thing we're going to examine is factoring out the greatest common factor. So anytime you're factoring any quadratic, anything at all, if there's a common number or a common variable across all the terms, pull that out first, so that way everything else you have to deal with is smaller. Sometimes that's all you can do. Other times you can do more. So I've got a few examples to work through here for you. So the first one is just kind of examining what factoring is all about. And factoring is the undo process for distributing. So here, if I distribute the 4 across the parentheses, across the subtraction, I'm going to have as an intermediary step 4 times 3x. And then I wrote it minus 4 times 7. You could write plus 4 times negative 7. Either way works as long as you end up with a minus 28 for that result. And we would get a 12x here. And oh look, that is exactly what we have on B. So we're using the distributive property backwards. I'm thinking of a term, I'm trying to figure out a term that factors out of all of these. Now, if you don't recognize the greatest one first, you don't have to. Just pull out a common factor. So here, even though we know we just multiplied 4 in, so 4 is the greatest common factor, I'm going to factor out 2 twice. So I just noticed 12 and 28, they're both even. All right, I know a 2 can come out. So there's a couple ways to think through this. One is if I'm writing times 2, then to compensate for that, I have to divide all the other stuff by 2. Or another way of thinking it is 2 times what would get me back to 12x. That's the way I usually phrase it. And in this case, that would be 6 with the x minus then 2 times what would get me 28, or half of 28 is 14. And now I look at my inner parentheses here, 6 and 14, still even. So another 2 coming out. All right, so there's our original 2 in green and our new 2 in pink. And when I pull this 2 out, that would be 2 times 3x minus 7. And then we're just going to multiply those two 2's together to get the 4 and the 3x minus 7, just like we had before. So this was factoring the greatest common factor out of 2 terms, but it was showing you that give and take, how it's the same as the distributive property, just looking at it backwards. All right, so we got a few examples down here. We just did 6x minus 14. But yeah, they're both even. So pull out a 2, 3x minus 7. All right, 7 here has got a lot more going on, more interesting. So I have 14f to the third plus 21f squared plus 28f. These are not like terms. I cannot combine any of these because they all, while they all have the same variable, they don't have the same variable to the same power. But since they do all have the same variable, the variable is part of what I can factor out. And again, you can do this, just pull the f out or do it all as one step. So I know I'm going to pull the f's, one f out of all the terms. And then I look, I've got 14, 21, and 28. Hopefully those numbers kind of ring a bell. You can also just look at the smallest. 14 is divisible by 2. 21 is not. So 2 is not a common factor. So then the other potential factor to consider here is 7. And all of those numbers are divisible by 7. So the 7f is our greatest common factor. And now we're going to write what I sometimes term the leftovers. So if I pull 7f out of 14f cubed, now remember, this is not pulling out by subtraction, but pulling out by multiplication division. So really, 7f times what would get me back to 14f cubed. Well, 7 times 2 would get me back to 14. I'm factoring out 1f, so that leaves 2 of the f's inside. Plus, now we play it again. I'm factoring out 1 of the f's. 7 out of 21 is 3, and now it's just with a single f, plus the f for this term is now out front, and then 7 goes into 28 4 times. So there's our factored form. 7f onto 2f squared plus 3f plus 4. Now our goal is to head towards factoring something like this, although in this case I don't believe that quadratic actually factors. But on your homework, if it says factor completely, look for a greatest common factor, then look to see if the rest factors. Sometimes it will, sometimes it won't. It's kind of hit or miss just depending on the way Connect Math loads things. All right, we got 2 more. So if you want to take a sec and write down what you think the greatest common factor is going to be and try factoring it out, feel free. Now I will go. So I have 20 m to the third, n to the fourth, 5 m squared, n squared. All right. Well, 5 is prime, so I can either factor out a 1 or a 5, but I can indeed factor a 5 out of the 20, so, whew, that was, all right, we got our 5. Now let me look at my m's. I've got m to the third and m squared. So it's not that I'm going to pull 5 m's out because those are m's in 2 different terms. So distribution is everybody gets one. Factoring is everybody puts one back, or however many they can all put back. In this case, the first term has 3 m's it could give up. The second one only has 2. So the most I can pull out where everybody gives back equally is 2 m's. So that's m squared, and then n to the fourth n squared, so it is also an n squared up front. And now we figure out our leftovers. So 5 times 4 would get me back to 20. M squared times m would get me back to m to the third, n squared, and that m does not look right. And then m squared, m n squared. Plus, well, if I have the 5 out front, that is a 1, which you can write. Sometimes you need to. But let's check our variables. M squared, n squared. Oh no, that is everything I just factored out. So remember before I said this was multiplication division. So if I have a thing divided by itself, I get 1. If I multiplied 5 m squared n squared times 1, I would get back to that second term. So that is our factored form. And then number 9, trick question. A to the third plus 2bc. Now this doesn't mean that there is no greatest common factor. It just means that the greatest common factor is rather boring. So what is the one number I can always multiply by or divide by and not change the value? And indeed it is 1. So our greatest common factor here is the number 1. And that is how we leave it. We do not attempt to find the values or anything like that. Is all we do. Alrighty. Next up, I'll be looking at some factor by grouping, which we are going to use to factor quadratics. I've got a couple methods for you guys to use. And I know some of you guys have been working pretty hard on Connect Math. Thank you for that. You've got some good progress. Your first homework assignment should be opening up soon. So be on the lookout for that. And Alex, even if you click assignments, you may not see it on the first page, so you have to scroll to find it. Cheers.